Good morning, guys. Anjani Kumar here, dealing the instrumentation subject for final year electrical students. In a last session, we discussed about periodic signal and aperiodic signals, right? So, what is a periodic signal? What is a periodic signal? Means the signals which repeats for a particular period of time, so a particular interval of time, so that we can call it as a periodic signals. And mathematical representation is x of t is a periodic signal, and that means it shadows by x of t plus t. So where t is called as a time period, the lowest value of a interval of time, the lowest value of time interval, that we can call it as a period, right? If you know the period, you can easily find out the frequency of a signal, right? So if the signal which doesn't satisfy this rule, that type of a signal, that we can call it as a periodic signal, right? And we discussed about continuous. Continuous means continuously varies with the time. That means each and every point of time will get the magnitude of a signal. Discrete interval of time, that we can call it as a discrete time signals. So we won't get at any point of time the value of a magnitude of a signal. We won't get these type of signals, right? Now we'll discuss about what are the differences between periodic and aperiodic. Very, very important differences. Periodic, aperiodic. Now you will get a short answer question, right? The first point. So periodic means, so it can be defined mathematically, right? That means x of t is equal to x of t plus t. The mathematically involved is there to find out that value of a signals, but so we don't have any mathematical equations. We don't have any mathematical equation representations. Next, value can be determined at any point of time. So that means at any point of time you can determine the value. For a non-periodic signal, the value should be difficult. That means if the signal is like this, so what is the value here? It should be very difficult to find out the value at a particular point of time. Alright, after that, so these are deterministic signal. Deterministic signal, each and every point of time you can determine anything, right? These are random signal. Random means you don't know, unknowing things are matter. So what are the difference? It can be mathematical equation representation is there. For a periodic signal, there is no mathematical representation. And second one is the value that can be determined at any point of time. So these are deterministic. These are random. So value that can be any point, it should be very difficult, right? So what are the examples of a periodic signal? That means what are the examples of a periodic signal? That means a sine wave, cosine wave. These are periodic signals. So what are the examples of periodic signals? A ramp signal, parabolic signal. These are the examples, right? So these are the differences between the periodic signal and aperiodic signals, right? So periodic signals means it has a mathematical representation, but in the case of aperiodic signal, you don't have any mathematical representation. The value that can be determined at any particular time also discussed, derived from the periodic signals, and it's very difficult from the non-periodic signal. And these are a deterministic signal. These are random signal. Non-periodic signals are random signals. And the examples are sine wave, cosine wave for a periodic signal, and a ramp signal and parabolic signals for a non-periodic signals, right? So now we will move on to the concept of how to find out the periodic signal. If the signal is a periodic signal, what is the frequency? What is the time period of the signal? So that is very, very important concept. So that we are going to discuss. So try to analyze. Checking periodicity. So there are some rules to check whether the signal is a periodic signal or not. You have to check. So basically we have two types of signals. That means continuous signal and discrete time signal. You know the continuous signal, the signal which continuously varies with the time, and discrete interval of time. How the continuous time signal will look like, right? So what is a discrete time? Discrete interval of time, right? The continuous signal, if you want to check the periodicity, there are one set of rules. For a discrete signals, if you want to check the periodicity, there are several rules. For a continuous signal, what is the time period? T. So for a discrete time signal, what is the time period? N. We already discussed about these things, right? Now we'll follow the steps. For a continuous signals that I'm going to prove the steps here. After that we'll go for a discrete time signals. First you have to find out what is the angular frequency, omega. Right? So from the given signal, you have to find out the omega first. Right? First step, you have to find out what is omega. With that, find out the frequency. You know how to frequency, omega is equal to 2 pi f. So with that you can find out the frequency. With that you can find out the time period. T is equal to 1 by f. So this is the third step, second step and third step. Right? Now first find out the omega from the given question. After that find out the frequency. After that find out the time period of the signal. Right? After that you have to solve x of t is equal to x of t plus t. That means time period ni add chesina kuda you are getting the same input waveform, right? So if you want this type of solution, then the signal is a no problem. We'll solve the example after this. Then the signal is a periodic signal. Otherwise the signal is a non-periodic signal. So the first step is find out the omega value and find out the omega value. So from that you have to find out the frequency, second step. That means omega is equal to 2 pi f. So with that you have to find out the frequency. After that, so find out the time period. So what is the time period? T is equal to 1 by f. So if you know the time period, then you know the equation. If input x of t is a sinusoidal periodic function, that means x of t plus t also sinusoidal function, right? That means 2t also the same input, 3t also the same input that you will get. So if it is satisfied, then the signal is a sinusoidal periodic signal. Otherwise the signal is a non-periodic signal. So one thing is clear. Now we'll go for discrete time signal. The same steps. For a given signal, find out what is omega. The first step is same from continuous and the discrete. The step is same for this. Next, second step is find out the frequency. So from that omega is equal to 2 pi f now. So with that you have to find out the frequency. Right? Then third step, you have to find out the period. So find out the period n. How you can find out the period? So if you know the f, so it can be in the form of k by n. Right? So k is a constant value. N is a period value. Right? If f is a rational number, if If f is a rational, then it's a periodic signal. If f is irrational number, that is non-periodic signal. Right? First, you have to find out the omega value. So with that you can find out the f. F can be in the form of k by n. So from that, n is a period, k is a constant value. If f is a rational number, so then it is called a periodic signal. If f is a irrational number, then we can call it as a non-periodic signal. Right? So what is meant by rational and irrational numbers? Right? Rational means, you see, rational means, that means 1 by 2. So 1 by 2, right? 11 by 2, so 13 by 6. So these are rational numbers. That means irrational numbers means root 2 by 3, right? Or pi by 3, or 3 by 2 pi. These are irrational numbers. If it is a rational number, then it is a periodic signal. If it is a irrational number, then it is a non-periodic signal. So in the form of thing, you have to find out whether the signal is a periodic and non-periodic signal. First, there are continuous time signal and discrete time signal is there. For a continuous signal, find out the omega value. With that you have to find out the frequency. From that you have to find out the time period. So from that, if the equation satisfies x of t is equal to x of t plus t, if this equation satisfies, then the signal is a periodic signal. Otherwise, if the signal is a periodic signal, this is the time period. Right? Otherwise, the signal is non-periodic signals. Right? And the second concept is for a discrete time signal. Similarly, the find out the omega value. From that you have to find out the frequency. The frequency in the form of k by n, where n is a period. If f is equal to rational number, then that signal is a periodic signal. If the f is irrational number, then the signal is a non-periodic signal. If the signal is a periodic signal, what is my period? The n you are getting, this is a periodics. The period of a discrete time signals. Right? So this is a concept regarding how to check whether the signal is a period or not. Now we'll go for examples. These are very, very important session. So you have to solve some problems here, whether the signal is a period or not. Right? Now we'll solve the first question. First we are discussing discrete time signals. Discrete time signals, you will solve the problems, right? First problem is given sine pi by 4n. Check whether the signal is a period or not. So first, what is the step? Find out the omega value. So this is in the form of sine omega t now. So what is the omega? Pi by 4 now. So first step is over. From that you have to find out the frequency. So what is the frequency? You know that omega is equal to 2 pi f now, where f is equal to omega by 2 pi now. So what is that omega? Pi by 4 by 2 pi. So what is that value? F is equal to 2. Right? Omega equal to 2 pi f. F is equal to omega 2 pi. That means something mistake is there. So omega by 2, what is the omega value? Pi by 4 na? Into 2 pi. So what is that value? F is equal to 1 by 8. Right? So F is equal to 1 by 8. So F value got 1 by 8. So in what form F is equal to? K by n. So K is a constant, n is a period. If K by n is a rational or irrational, we'll see 1 by 8. So it is a rational number. If it is a rational number, it is a periodic or non-periodic? It's a periodic. So what is a period? N is a period. So what is that n? 8. So period is equal to 8. So this is the solution for this. See, so given signal is sine pi by 4 n. So this is a discrete time signal. So you have to find out whether the signal is a periodic signal or a periodic signal. So first find out the omega. So what is that omega? Omega is equal to pi by 4. So from that you have to calculate the f. F value should be 1 by 8. You got 1 by 8. So it is in the form of k by n, right? It is in the form of k by n. It is a rational number or irrational number. Is there any roots or pi or a special character is there? There is no root and pi value. So that's a rational number. If this is a rational number, my signal is a periodic signal. So what is a period? If the signal is a periodic, what is a period? Period is k by n is a period. Na? It is 1 by 8. Na? What is the n value? N is equal to 8. So n is 8. And one more question will solve. The second one. Sine square pi by 4 n. Sine square pi by 4. It is not in the form of sine omega t. This is sine square theta form. So how you can write sine square theta is equal to 1 minus cos 2 theta by 2. Alright, so note down. So 1 minus cos of 2 theta means pi by 4. Pi by 4 n by 2. 2 get cancelled. So 1 by 2 minus 1 by 2 cos of pi by 2 n. So from this is the formula. So what is the omega? Omega is equal to pi by 2. This is omega, na? This is omega. From that, what is p? 2 pi f is equal to pi by 2. Right? F is equal to 1 by 4. 1 by 4 is that is equal to in the form of k by n. Right? If it is a rational or irrational? Rational number. So it is a periodic or non-periodic? Periodic. So what is the period? 4 is a period. Right? So with it you will say whether the signal is a period or not. So these are the examples for continuous time signal. Now we'll go for another type of model. Right? Similarly, so you have to represent this form in the form of sine omega t. So from this you will get 1 minus cos 2 theta by 2. So with that you can find out the omega value, substitute and find out the f value. From that you can calculate whether the f is a rational number or irrational number. So with that you will tell whether the signal is a periodic or periodic. If the signal is a periodic, and what is the time period? So k by n, well, there n is a period value. Next we'll solve another model, right? Third model. Here you are having two functions, sine 2 pi by 3n plus cos pi by 2 n. Find out whether the signal is a the signal should be a periodic signal or a periodic signal. If it is a period, find out the time period. Right? If it is a periodic signal, find out the time period. First you have to take this one. After that you have to take this one. Here what is omega? 2 pi by 3. So from that what is f? That means 2 pi f is equal to 2 pi by 3. F is equal to 1 by 3. You know the f. K by n. If it is a rational or irrational? A rational. So periodic or non-periodic? Rational. What is a periodic? What is a period? N is equal to n1 is equal to 3. You got n1 is 3. Correct? And again this one. So from here what is omega? Pi by 2. So from that what is the frequency? That means 2 pi f is equal to pi by 2. Pi get cancelled. F is equal to 1 by 4. So it is in the form of f is equal to k by n. Right? So it is a rational number. 1 by 4 is a rational number. Now it is a periodic signal. So what is the n value? N is equal to 4. N2 is equal to 4. Now what is a period? So what is this? There are two periods, n1 and n2. What is the actually period for this signal? That means n is equal to LCM of n1 and n2. So what is the total period? LCM of 3, 4. What is that value? So total period should be 12. So in this way you have to calculate if the two functions are present in the system. So first find out the n1 value and find out the n2 value. From this you have to calculate the period value. Right? For suppose if another one is given, right, sine 3n, right, what is that? Omega is equal to 3, right? So what is f? 2 pi f is equal to 3. F is equal to 3 by 2 pi. That means f is equal to k by n. If it is a rational or irrational, 3 by 2 pi. Pi is there, it is a irrational number. Alright. If it is a irrational number, it is a periodic or non-periodic? It is a non-periodic signal. Right? If the signal is non-periodic, you don't want to find out the periodicity. Right? You don't want to find out the time period of a signal. Right? So in this way, you will calculate whether the signal is a periodic signal or a periodic signal. So with that, if the signal is a periodic signal, what is the time period? So what are the steps you have to follow? First, to find out the omega value. I will write it here. So first find out what are the steps you have to find out? First to find out the omega value. So from that you have to find out the frequency value. From that frequency in the form of k by n. So with that, if it is a rational period, if it is irrational, it is a non-periodic signal. If it is a period, this is my period. N is my period value. So in this way, you will calculate it for every signal. Now we'll go for a continuous time signals. So with that, we'll finish this thing. Now we'll solve it for continuous signals. Right. So given 2 cos t by 4. Alright. 2 cos t by 4. Similarly, find out the omega. Omega is equal to 1 by 4. Na? So from this, find out the frequency. 2 pi f is equal to 1 by 4. F is equal to 1 by 8 pi. So second step is over. First step you find out the omega. Second step you find out the t. And third step you find out the time period. So what is the time period? 1 by f. So 1 by 8 pi. So what is the time period? That is equal to 8 pi is the time period. Now we'll go for a mathematical equation. So what is that mathematical equation? So x of t is equal to x of t plus t. If it is satisfied, then my signal is a periodic signal. T is my fundamental period or time period, right? So from here, what is x of t? So given equation 2 cos t by 4, right? So what is x of t plus t? So what is x of t plus t? 2 cos t by 4 plus what is t? T value should be 8 pi, right? So what is that value? 2 cos of t by 4 plus 8 pi. It is in the form of cos of n pi plus theta, right? So if n is the even number, cos of n pi plus theta equal to cos theta. If n is even number, cos of n pi plus theta is equal to cos theta. So from this, n is 8 pi. 8 is nothing but even number. So what is that value? 2 cos of t by 4 itself. It is nothing but in the form of n pi plus theta. Right? N is even, cos theta. Theta is 2 by 4. So from this you will get x of t is equal to x of t plus t. Right? If it is satisfied, whatever the x of t, you will get x of t plus t also. Then the signal is a periodic signal. Right? So what is the period? So what is the period? Period is nothing but t. So what is the period? 8 pi. In this way, you calculate it for continuous time signals also. Right? So it's very easy to understand, right? And another model, right? And another model of representation. For suppose if you got t1 is equal to 3, t2 is equal to 7, if both the signals which is having a time period omega కనుక్కుంటా, omega నుంచి frequency కనుక్కుంటా, frequency నుంచి t1 కనుక్కుంటా, omega కనుక్కుంటా, omega నుంచి frequency 2 కనుక్కుంటా, from that you will calculate the t2. Then what is a fundamental period? So fundamental period means the lowest value of a time. So that is called a fundamental period, right? The lowest value of time period we can call it as a fundamental. There are two time periods. What is a fundamental time period? So how you can calculate it? So take LCM of T1 and T2. You will get 3 into 7. What is an LCM? 21. So this is the fundamental period of this given waveform. Or else if T1 is equal to in the form of 2 pi by 3, T2 is equal to in the form of 2 pi by 7. How you can find out this fundamental time period? Now how you can find out the fundamental period? So LCM of numerator, that means 2 pi comma 2 pi by HCF of denominator, that means 3 comma 7. So what is the LCM here? 2 pi. What is the HCF? Highest common factor, and only one. 1 into 3, 1 into 7. So what is the highest common factor? Highest common factor 1. So what is that value? 2 pi. That's right. What is the fundamental time period? T is equal to 2 pi. If it is in the form of fraction form, how you can calculate the LCM of numerator by HCF of different denominator? With this you will find out the fundamental time period. Or else in the form of, if T1 is equal to 1 by 2, T2 is equal to 1 by 4. If it is like in the form of, then fundamental LCM of 1 comma 1 by HCF of 2 comma 4. LCM of 1 comma 1 ఏమవుతుంది 1, HCF of 2 comma 4, 2 కి 2 into 1, 4 కి 2 into 2. What is the highest common? 2. So what is the fundamental time period? 1 by 2 is my fundamental time period. So in this way you can calculate it, right? So like that you will solve the equations, right? You will solve whether the signal is a periodic signal or not. From that you will check what are the functions. First you have to find out the omega, after that frequency, then find out the t. From that x of t is equal to x of t plus t. If it is solved, then the signal is a periodic signal. Or else here omega f, from that f is equal to k by n. If k by n is a rational number, signal is a periodic signal. Irrational number, signal is a non-periodic signal, right? Thank you very much.